Okay, so in this section, this is 3.5, we're working on taking a look at solving a work schedule using a linear program. So here's an example. It's the post office problem. And our post office scheduling, um, well, we'll have our days here, day of the week, and then we'll have the number of employees that we need. And we'll have to work 7 days a week. Although some days we won't have to man the front desk, for example. And so these are the number of people we want: 15, 19, 14, 15, 19, 14. Wait a minute. Let me pause here for a second. Let me get the table right. Okay, here's my table. And so the right hand side again is the number of employees that we need for each day. Now, the problem here is that our employees are working 5 on and 2 off. Okay, so we have to be careful about making sure that employees have consecutive days off. We also should recognize, let's see, that 7, we can have a 7 and a 1 off. Okay, so if we have, so we can work up to day 6, right, is what I'm talking about, and then we would have the day 7 and day 1 off. Okay, so let's see, how would we define our decision variables? Well, let's see. How about if we let xi be the number of employees working day I, right? Then, that doesn't seem right, does it? Because, for example, you could just let x1 be 17, x2 be 13, x3 be 15, and so on. So what am I not taking into account here? I'm not taking into account this 5 on 2 off schedule. And so how about if I need to change this to account for that? So instead of saying it's going to be the number of employees working day I, how about if we say it's the number of employees starting their shift, starting their week on day I, right? And so, for example, how many workers do you have on Monday, on day 1? So day 1 is Monday. Who's working? Well, of course, x1 is going to be working. X2 will not be. X3 will not be. What about x4? Well, that's 1, 2, 3, 4, 5. So x4 will be working. And so x5 would be working, and then x6 would be working, and x7. Okay, and so for day 1 then, we would have x1 plus x4 plus x5 plus x6 plus x7, and so that needs to be greater than or equal to 17. Good. So similarly, who's working day 2 or shift 2? Well, day 2. Well, day 2, we would have x2, right? We would also have x1, by the way. So x1 and x2 are working day 2. How about x3? Is x3 working? No, because they would have that day off. How about x4? Would x4 be working? They'd also have x3 off, or x2 off, sorry. And so therefore, let's see, x5 would be working because that's 1, 2, 3, 4, 5, right? And so x5 would be working, x6 would be working, and x7. Okay, so we see that x1 would be working, x2 is working, 3 and 4 are not, 5, 6, and 7 are working. Good, and then we'll send those up, and so that'd be greater than or equal to 13. Good, and so you see how we're going to do this for the rest. Very good. All right. And then what is our objective function? I'll let you come up with the remaining constraints. The objective function is going to be that we're minimizing x1 plus x2 plus x6 plus x7, right? Good. Oh, by the way, we do have the constraint that xi is greater than or equal to 0. Now it's interesting in this problem, interesting to note, if you solve this in Excel, you get that x1 is equal to 6 1/3, x2 is equal to 5, x3 is equal to 1/3, x4 is equal to 7 1/3, x5 is 0, x6 is 3 1/3, and x7 is 0. Well, there's some issues, right, with our solution, because these should really be integers. And the interesting thing to note is that we can't just round off these numbers to get the actual. So actual optimum is going to be x1 equals 4, x2 equals 4, x3 equals 2, x4 equals 6, x5 equals 0, x6 equals 4, and x7 equals 3. And you might notice that this solution is completely different than the solution that we got in Excel. So this actual optimum was actually, we couldn't use the normal optimizer for this. We had to get a new, what's called an integer program. So to get this solution, we had to use integer programming. So that's just a little note that if your solution should be integers, you can't just use the normal optimizer like we would normally do and just round them off because you typically won't get the right answer. Good. All right. I've got one more example I wanted to set up. Let's see, can I do it in 2 minutes? So the idea here is that I just wanted to show you that it is possible to have different kinds of decision variables. Okay, so in this case, this is actually exercise 2 in section 3.5. You know what? I think I'm going to go ahead and stop the video here, and we'll go ahead and restart the video for this example in the next one. See you then.